Cheers, Victoria. So today I'm going to talk about the climate resilient assessment that we've conducted for an early years hub that we're planning at Brunswick. As Victoria alluded to, this has come from the climate risk strategy and trickled through to a requirement in our buildings, sustainable buildings policy, which we've just we're in the process of updating now. And probably 2 weeks before we embarked on this, we thought, well, why don't we conduct climate resilient assessment for projects that are over $10 million? 2 weeks later, a project that was over $10 million has come through the pipeline. So we've decided to trial this process. We concurrently are doing other climate resilience assessments on existing buildings, and that's going through a consultant pathway. But this process is internally conducted with our sustainable built environment team. And so the project is for 138 kindergarten spaces, just over $11 million. And the image that you see was just a preliminary concept. It is not going to look like that. I guess the other points to make that kind of push this, in addition to the update to the policy, was having my role, which is the Sustainable Buildings Officer, is relatively new since November. So to have that resource in between the environment and the capital works team has been really important to kind of kick the can along. So I'll run through really quickly. I'm conscious of time. So the method that we have adopted is largely in line with the Australian Standard 5534 climate change adaptation. And so I'll run through each of these real quick, but we look at the historical data, the site conditions, the hazards, the impacts, then we run a risk assessment, then we do adaptation planning, and then obviously implement and review as we go. And then on the right, you can see we've got the nexus between hazard, vulnerability and exposure, which is risk, and then the impacts, which I guess then become the risks that we have to look at. So the historical data, we go to the Bureau of Meteorology and pull the data from the closest weather station, which at this location was Essendon. So it is 9 kilometres away, but it's the closest. So we have the data ranges from 1923, 1939 to 2023. So we've got quite a bit of data there. And then in this process, we write an observation at every stage. So we've got some highlighted things here. We can see all the highest temperatures have all essentially, out of 10 of the 12 months, have come after 2005. And then you can see some of the drier months are also in the last couple of years. So the overwhelming observation is that we have a drier and hotter climate. Then we move on to the existing site conditions. So we've got some access to some internal flood modelling data, and we can see on the left that's got the 1% or the 1%, the 5%, and the 20% AEP overlaid, and then on the right we've got flood hazard rating as well, which is also another interesting metric. This was particularly interesting at this point. We kind of involved a few more internal stakeholders because the flooding is happening from stormwater overland flow, because this street does not have underground stormwater infrastructure. We're doing another project in the park to the west, and so we invited the manager of capital works. We had the unit managers of drainage and road infrastructure and IWM to discuss is the works to the park going to mitigate any of the flood risks? B, if not, are we planning in the next 10 years to build that under road infrastructure to take this water off the road? And then if not, we'll need to focus more on the building. So the answer that we got was neither of those two, the park or the infrastructure, was planned to reduce the flood risk. So we've then kind of got the green light to at least proceed with this with our advice and try and make the building itself more resilient to flood impacts. We've also looked at some urban heat impacts and some of the modelling there. I really like it when you look at a heat map and you see all the trees are blue and all the car parks are red, it's a good justification to kind of swap those around. And then we've got the DELP data on the right, which is the larger. I think it is. I'm kind of blanking on the word right now, but the size of the parcels is larger, so you can't see the granularity of the urban heat. But these are impacts that we all know and expect, but it's just good to get that data under your belt. We then kind of go back to the baseline data again, and we're getting this. The data we use is the VCP19. There might be newer ones. If anyone's got a more up to date data set, please send it through. So we use the baseline and we kind of overlay the VCP19 on top of that and just extrapolate out some of the mean max, the mean minimums. You know, like what are we going to see in terms of rainfall across, you know, the seasons, and just confirm, I guess, our expectations of a warmer and drier climate. And again, write some observations around that. I think particularly interesting is if you go to RCP 2074.5, we're looking at a potential reduction in spring rainfall by 15%, but the intensity of the wettest day might be 10%. So trying to balance out, it's going to be dry, but we're also going to have more intense rainfall events as well. We then move on to extrapolating out some impacts, and so we do a bit of research and see what's out there in terms of how particular infrastructure or you know, building the components or communities and community segments react to certain impacts, and then try and identify those impacts across. We use the 5 capitals in this case. It aligns to the 4 pillars of sustainability, which we're adopting across the council. So not just looking at environmental, but the social and the cultural impacts as well. And then so we extrapolate all those out. I've just been given the notice to hurry up, so I'll keep going. Then we jump into the risk assessment. This is all pretty basic risk assessment stuff. And that's kind of a screenshot. It's really hard to see, but essentially we run that across all the scenarios, and what is the consequence? That never changes. It's the likelihood that's changing as the weather gets more volatile. We then go into adaptation action planning, and so for each of those impacts or risks, we identify things the building could incorporate to reduce that risk. And then some of the co-benefits, the costs, assumptions, who needs to be involved, how that would be, like the documentation that will have to be included in, and then we implement. So after all that happened, a report was drafted. It had 15 upfront actions. We had over 71 impacts, and then that probably had 100 plus actions. But we consolidated that down to 15 key actions which addressed multiple risks, and additional 4 operational actions which are more about mental health support for staff and the children that are going to be in the hub. And so a lot of the actions are around that flood risk at the front, increasing the permeability, rainwater tank, having a freeboard above the 1% AEP, dual aspect play spaces and adequate canopy and shading to reduce the urban heat impacts so the kids can still play outside and not get smacked by the western sun. It's presented to the project sponsor for comment and then provided to the project manager to provide to the appointed architect, and that process has just happened, or it's happening in the next week. And then after an inception meeting with the architect, we'll have a workshop with them, the project manager and the project sponsor, to discuss the 15 actions and how we can incorporate those into the design to make it more climate resilient. We're now looking at running a similar assessment process for a precinct, which will be an in-person workshop with internal officers. And we're starting to look at how we can do this for infrastructure in the future, but on a much smaller scale, because we don't necessarily need to identify 100 plus actions. We'll skip the Q&A. Here's the contact if you have any questions after today's event. Thank you.